Hello everybody, welcome to part 2 of exam 3 for Math 1813 review. So we'll go ahead and start right off. So this section will be section 6C.4 or right triangle trigonometry. So number 13 states, find the missing side lengths R and Y in the given triangle, round to 1 decimal. So we have a triangle and I'm going to draw it a little bit bigger just so we can see it a little bit better. And it is a right triangle, and we know this angle right here is 26 degrees. And we know this side's R, this side's Y, and we know this side is 3.6 inches. So, if we remember SOHCAHTOA, this actually can be really easy. So, we have this angle, theta, and we have this side length adjacent to it. So, I'll go ahead and say this is the adjacent side, this is the opposite side, and this is the hypotenuse. So, if we have the angle and the adjacent side, we can find the opposite side with TOA. And if we have the adjacent side and the angle, we can find the hypotenuse with CA. So, let's go and find the hypotenuse real quick. So, cosine of our theta is going to be our adjacent over our hypotenuse. So, cosine of our 26 degrees is going to be our 3.6 inches over our hypotenuse R. So, if we do some simple algebra, move stuff around, we get R is 3.6 inches divided by cosine of 26 degrees. And this results in R being about 4.0 inches. Right, because we have to round to 1 decimal. Now I will say, make sure that when you're doing your calculations, you don't round until the very last step. Because sometimes if you round early on, your calculator might miss some significant figures and you might round to the wrong thing at the very end. Alrighty, so given all of that, let's go ahead and find our other side. So I'm going to move this over. And we said TOA, so tangent theta is our opposite over our adjacent. So tan of our 26 degrees is our opposite side, Y, over adjacent side 3.6 inches. So that means Y is 3.6 inches times our tan of 26 degrees, which means our Y is roughly 1.75583, or if we round to 1 decimal, that'll be 1.8 inches. And that makes sense because we want our R to be the longest side, right? Alright, next triangle. Now, same idea, but this time we're dealing with our angle measure in degrees. So first and foremost, we are given that it is a right angle. We are given this angle up here is 2 pi over 7. This angle here is theta. This side is y. This side is x. And this side is 5.3 centimeters. So again, let's go ahead and start and label each side. So 2 theta, this angle, this side is this side's a hypotenuse regardless, right? 2 theta, this is the opposite side. Right, so I'll make our theta related stuff black. And this is our adjacent. Now, we have another angle here. We have this angle, 2 pi over 7, right? And to this angle, our opposite is our 5.3, and our adjacent is our x. So just remember this because we can use both angles to find our sides. So if we remember SOHCAHTOA, like we did in the top one, if we're trying to find x or y, we can use either angle, right? But let's go ahead and find theta first. If we remember our entire triangle, all 3 angles in our triangle should add up to 180 degrees, right? So if we know this one's a right angle, we know that's 90 degrees. Oh, so it's 180 degrees or pi, right? So we know that our right angle is 90 degrees or pi over 2. And then we know this other angle is 2 pi over 7. And we know our theta all should add up to pi, right? So let's go ahead and make these have common denominators. So that's 7 pi over 14 plus 4 pi over 14 plus theta over pi. And I'll go ahead and put pi over 14 over 14. So then that means our pi should be 14 pi over 14. So it's 11 pi over 14 plus theta is equal to 14 pi over 14 minus 11 pi over 14 pi over 14. Theta is 3 pi over 14. Okay. So now that we know 3 pi over 14, we can use either of our angles given to find our opposite and adjacent side. Right, so let's use our 2 pi over 7 because we know that one off the bat, and just in case so we don't get lost, in case we miscalculated theta, right? So we know that using this angle here, in order to find our x, it's an adjacent side, so we know our opposite side, so we're going to use TOA. Tan of theta is equal to our opposite over our adjacent. And we're doing the blue version. Actually, let me highlight it in blue. We're doing the blue version, right? So the blue angle, this one. And so we're doing the blue here. But it's just whatever way you decide to label it. So tan of our angle, 2 pi over 7, equals our opposite side, which is 5.3 centimeters, over our adjacent side, which is x. And if we're looking for x, if we do some math, we will get x is 5.3 centimeters over our tan of our 2 pi over 7. And that will get us roughly 4.2266 centimeters. Or if we round to 1 decimal, it'll be 4.2 centimeters. Alrighty, now y, we would do the same thing. It is our hypotenuse, and we're given the opposite side, so we can use so. And I'll go ahead and do it on this side. Sine of theta is equal to opposite over our hypotenuse. And we know our theta was that 2 pi over 7 is equal to our opposite side, which is our 5.3 centimeters, over our hypotenuse, which is y. And from there, we know y is equal to 5.3 centimeters over our sine of 2 pi over 7, which comes out to be 6.7789, or just simply with 1 decimal, 6.8 centimeters. Alrighty. Third question says, a line passing through the origin and point P equals A10 forms the angle pi 8 with the x-axis. Find the missing coordinate of P, round to 1 decimal. So I'm going to go ahead and draw out our little XY coordinate plane. And we know we have a point A10. Some line is passing through the origin. And we have a point 8 or A10, which I'm going to just plot right here. A10, our point A10, P, right? Because that's what was given there. And it says it forms an angle of pi over 8. So we know this angle here, right? So if you notice, this is actually just a triangle, right? Just a nice little triangle. So let's go ahead and draw this triangle off to the side. Just like that. And it is a right triangle. And it has an angle here of pi over 8. And we know that we have some base A and some height 10. So if you notice, these look just like the other problems, right? To this angle, this is our adjacent side. And this is our opposite side. So we are given our opposite. We need to find our adjacent. We have a theta from our SOHCAHTOA. We will be using our TOA. Tan of our theta is equal opposite, which we know, over our adjacent, which we can find out. So tan of our pi over 8 is equal to our 10 over our A, our adjacent side, which, moving some stuff around, A is equal to 10 over tan of our pi over 8, which means A is roughly 24.142. And if we went around to 1 decimal, A is equal to 24.1. Alrighty, so let's go ahead and move on to our next section here. So 16 says, if t is an acute angle such that sine t is 5 minus x over 5 plus x for a positive number x, find the values of the other trigonometric functions of t in terms of x. Alrighty, so just like with the last one, I'm going to go ahead and start with our little xy coordinate plane. And we know that it is an acute angle for some positive number. So I'm going to just, because it's an acute angle, I'm going to plop it in our first quadrant. So somewhere here, right? So we have some angle T, and we have some triangle here. Highlight it like I did the last one. We have some triangle here. So let's remember one thing real quick though. If we know sine t is 5 minus x over 5 plus x, let's not forget this from SOHCAHTOA, that sine is simply our opposite of our hypotenuse, right? So according to this triangle here, which I will redraw right here, slightly bigger so we can see it better. If this is our angle T, and we want to know our opposite side, that's this side. Our opposite, according to this right here, our opposite side is that 5 minus x. Right? And our hypotenuse, which is this, is our 5 plus x. Correct? So our adjacent from our lovely Pythagorean theorem, we can find it by saying that a squared is equal to c squared minus b squared. So a is equal to the square root of our 5 plus x squared minus 5 minus x squared. So 5 plus x squared would be 25 plus 10x plus x squared minus, this would be our 25 minus 10x plus x squared. So 25 minus 25 goes to 0. 10x minus plus 10x goes to 20x. And x squared minus x squared goes to 0. So we're left with a is the square root of 20x. Or, if we remember 20 is 4 times 5x, we can pull out that 4 and say, we can pull out that 4 and say 2 square root 5x is our a. So I'm going to go ahead and draw that here. 2 square root 5x square root 5x is our adjacent side. So now we have all the sides, and we can come up with these lovely little cosine, cosecant, tangent, secant, and cotangent, right? So I'm going to zoom in, and I'm going to just make a little note of each of these. Cosine, if we remember, is adjacent over hypotenuse. Cosecant is the inverse of sine, or hypotenuse over opposite. Tangent is opposite over adjacent. Secant is the inverse of cosine, so 1 over cosine, or a hypotenuse over adjacent. And cotangent is the inverse of tangent, so that would be adjacent over opposite. So knowing all of that and knowing our little lovely triangle here, we can go ahead and put all of these on there. So cosine is our adjacent to square root 5x over our hypotenuse 5 plus x. Simple enough. Alrighty, so cosecant is hypotenuse over opposite, so 5 plus x over 5 minus x, which checks out because that is the inverse of what we started here. Tangent is opposite over adjacent. Our secant is hypotenuse over our adjacent, which is 2 square root 5x, and cotangent is our inverse tangent, so 2 square root 5x over 5 minus x. Alrighty, so moving on. Number 17 says, Josie walked 100 feet away from a light post. Then she measured the angle of elevation from the ground at her feet to the light and found it to be 20 degrees. How tall was this light post? So let's go ahead and draw a picture of this. If Josie is right here and she's walked a total of 100 feet, right? And there's some lamppost here. So let's make it a cute little lamp, right? And she knows that from her to the top of the lamppost, so this roughly here, there's an angle of 20 degrees, right? So this is Josie. And this is the lamppost. And she's trying to figure out how tall this lamppost is. So she's trying to figure out this height here. So this is our H. That's what we're looking for. So if you notice, according to this angle that we have here, we know this is our adjacent side. We know this is our opposite side. And we know this is our hypotenuse. And we're looking for our opposite, and we know our adjacent. So from SOHCAHTOA, we will be using tangent. So tan of our theta is going to be equal to our opposite over our adjacent, which is just saying tan of our 20 degrees is equal to our 100, our h over 100. So h is actually equal to 36.397, or if we round it to 1 decimal place, h is equal to 36.4 feet. So that means that lamppost is 36.4 feet in height. Alrighty, now number 18. The angle of elevation from the bottom of building A to the top of building B is 43 degrees. So that's our angle here. And then it says the angle of elevation from the bottom of building B to the top of building A is 22. So that's this angle here. How tall is building B? So this is where it gets kind of fun. I'm going to go ahead and split these up just to show y'all something. So this is my building A, which we know is 150 feet tall, right? And this is the ground between A and B. So A, B. So now I'm going to draw B, right? This is what we're looking for. And this is from B to A. So if you notice here, this distance and this distance are the exact same, right? The base of angle A to B, of triangle A to B, and the base of triangle B to A, exact same. So that means this angle here, 22 degrees, and this angle here, 43 degrees. We can use both of those angles and the side that we already know to find x and eventually to find b. So what I mean by that is, from this triangle here, our A triangle, we know that this is our opposite side, and this is our adjacent side. So from SOHCAHTOA, yes, I will write this every single time. From SOHCAHTOA, we will be using TOA, or our tangent function. So tangent of theta is equal to our opposite over our adjacent side. So tan of 22 degrees is equal to our opposite side, 150 feet, over our adjacent side, x. So x, from some quick calculations, is roughly 371.263 and some other numbers. And I'm going to leave it just there. I'm not going to round it or anything yet, because then, like I mentioned earlier, this can mess with your final results. So if we know x here, let's figure out what these numbers are in terms of our angle. So in terms of our angle, B is our opposite side, and x is our adjacent side. So again, we will be using TOA, but this time just a little bit different. So tan theta, again, opposite over adjacent. And I don't think it's a bad thing to rewrite this every single time. That way it clicks in your mind. So tan of our 43-degree angle is equal to our opposite, B, which is what we're looking for, over our adjacent, x, which we know. So B is actually equal to our x, which is 371.263 ... times our tangent of 43 degrees. So B comes out to being 346.2 ... feet. And we want to round it to 1 decimal place. So that means that we know the height of B is equal to 200. Oh, I don't know why I did that. 346.2 feet. Just like that. Alrighty. So, on to number 19. It says, Cassie measures the angle of elevation from the ground to the top of a pyramid to be 28 degrees. If the pyramid is 30 feet tall and the angle of elevation of its sides is 40 degrees, how far away from the pyramid's base is Cassie standing? So, essentially, this is our pyramid, right? Which it is shaded in gray, but just to solidify the image. This is our pyramid. Cassie is standing right here looking at the pyramid, right? We'll make Cassie have some hair. And Cassie's looking at the pyramid. From the ground to the top of the pyramid, notices that there's a 28-degree angle of elevation. And we know that the pyramid has a height of 300 feet. So let me not make that black. Let me make it a different color. There we go. So we know the height is 300 feet. And then we also know that the angle of elevation from the pyramid is this 40 degrees here. Let me not put it in front of the degree sign. So again, just like the last problem, I'm going to split these triangles up real quick. So this is just our pyramid. So this is our pyramid right here, right? And we have some distance here that we don't know. I'm going to call it D. Just some distance D. And we have some height, 300 feet. And we have some angle, 40 degrees. Right? Now I'm going to go ahead and draw out our triangle in terms of where Cassie's standing. So again, Cassie's standing here, looking at the top of the pyramid like that. And Cassie is at a distance X and D. So her distance is X plus D, right? And the height is still the same, the 300 feet. And her angle of elevation is 28 degrees up to that top of the pyramid, right? So what we can do is we can go ahead and find D here, plug D in here, and then look for X on that side. So let's do that. So again, let's look at this in terms of where the sides are relative to this angle. So to this 40 degrees, this side is the opposite side. And this side is the adjacent side. So if we remember SOHCAHTOA, we will be using TOA. So tan of our angle is equal to our opposite over adjacent, or tan of our 40 degrees is equal to 300 over our D. So from this and some simple calculations, we can find that D is equal to 357.526 ... And again, do not round until the very, 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 very end. Okay, so I'm going to go ahead and do that over here. Again, this on this other triangle. On this other triangle. So in reference to our 28 degrees, this is our opposite side still. And this is our adjacent side. Right? So I'm going to actually write this right here. Again, we will be using tangent. So tan of our theta, 28 degrees, is equal to our opposite over our adjacent X plus D. We found out from over here that D is 357.526. So our X will be equal to our X is actually equal to our 300 over our tan 28 minus our distance D that we came up with earlier. So from this and just some plugging into the calculator, we will get X is equal to our 206.6918 feet, and we want to round to the nearest foot. So X is actually 207 feet. Alrighty. Now we're moving on to a new section. Section 7.1, graphs of sine and cosine. Number 20 says, determine the amplitude, period, midline, and whether the graph has an x-axis reflection and or a vertical shift. And write a possible equation for the graph. So I'm going to go ahead and draw some things, just starting off. We know that our graph ranges from here to here, right? So this distance here is 4, which means our midline lies right about here, right? With 2 at the top and 2 at the bottom. So what does that mean? That means that our amplitude is 2, right? Alrighty, and then one thing I forgot to write down. Midline, we said it was roughly right here, which is actually at y equals 1, right? And then our period is actually, it's where the repetition happens. So our period, we can say ranges from here to here, or we can say it ranges from here to here. Either way, they should be roughly the same. So I'm going to actually say that from here, which looks to be in, let me change the color real quick. From here to here, it looks like it's almost 3 pi over 2 and 5 pi over 2. Oh, no. 7 pi over 2. There we go, 7 pi over 2. And I'm just saying that because it's right between pi and 2 pi and 3 pi and essentially 4 pi, right? So if we're looking for our period, we're just going to subtract the 2 minus 3 pi over 2. I get 4 pi over 2 or 2 pi. So that means every 2 pi it repeats, right? So now we will talk about vertical shift. So I notice here is a very clear vertical shift, right? From like an original graph. And that is a vertical shift of 1 unit up. But then if we look at that, I also notice that there is a reflection across the x-axis as far as normally this bump or hump or whatever you want to call it normally would start on the top if it was a graph of sine, right? So if we're saying that there is a x-axis reflection, now let's write an equation. So I mentioned it was a sine graph, and the reason I'm thinking it's sine, and you can essentially come up with it both ways. So we know there's a x-axis reflection, right? And we know there's an amplitude of 2. So normally that would be y is equal to our a sine of our period divided by 2 pi x, or 2 pi divided by our period, my bad. Two pi divided by our period x plus h if there's a horizontal shift, plus k if there's a vertical shift, right? So we know our amplitude is 2, and we know there is a reflection across the x-axis, so it would be a negative 2. Sine of our, we said our period was 2 pi, so that just goes to x, and there is no horizontal shift, and we do know there's a vertical shift of 1. Alrighty, now on to number 21. For the function f of x equals negative 4.2 sine x plus 1.1, find the amplitude, midline, domain, and range. So I'm actually going to scroll back up just so we can talk about what I had written here. Our amplitude is our first number, 4.2. Easy. It looks like we are flipped across the x-axis. So there is a reflection across the x-axis. So our normal sine graph looks something like. I definitely do that wrong. Our normal sine graph looks something like. Right? Something like that, I think. And basically, we're crossing here at 0, 0, and our amplitude is just 1. So this graph here is reflected. So it looks something like the opposite of this, right? But it's also shifted up 1.1. So it is still the opposite, but it's shifted up to here. So it's shifted up 1. So we're at the green line right now, right? And there's also an amplitude. So if our midline's somewhere here on our green line, we know our amplitude here is 4.2. So if we know our amplitude is 4.2, and we shifted from 0, 0, we shifted up 1.1. And we know our amplitude is 4.2, we can find out what our midline is. So our midline typically happens, I definitely drew this wrong, but our midline typically happens at our vertical shift point, right? So our midline in this case is 1.1. So now if we look at our domain is the same. We're going from negative infinity to positive infinity. And our range is going from, way to find a range is, normally our range would be going from 1 to -1. That would be our range. However, we added 1 to the top part. We added 1.1 here, and we subtracted 1.1 here. Right? And then we also have a amplitude of 4.2. So right here, let me make that a highlight. Right here, we know that went from 1.1, which we decided was this point here. Oh, no. We decided that from 1.1, there's an amplitude of 4.2, right? So our range actually goes from So our range actually goes from this 1.1 plus 4.2 and 1.1 minus 4.2. So 1.1 minus 4.2 is our bottom part of our range, or that. And the top part of our range is 1.1 plus 4.2. So that ends up being -3.1 and 5.3. So that means that our highest point we can reach on this green graph is 5.3, and the lowest point we can reach is -3.1. Alrighty, and that is it for our part 2 of our exam 3 review for Math 1813. Again, make sure you like this video, subscribe so you don't so you're updated for when part 3 is uploaded. Thank y'all. Y'all have a good one.